Last week we learned that a central angle is an angle that goes through the center or through the middle of a circle. And we learned that the measurement of this central angle and its intercepted arc, which is the arc that goes from one point to the end, are going to be the same. I'm going to use 100 just to make it a little easier. And we also learned that the inscribed angle, which is an angle formed by the intersection of two chords on a circle, is going to be half the measurement of whatever the central angle is and its intercepted arc. All right, so since we reviewed central angles and inscribed angles, let's get into the new material, which is on secants. So if you recall from the vocabulary last week, a secant or a secant line is a line that goes through a circle, intersecting the circle at two distinct points. A chord, which you just saw, is a part of a secant line. A secant line goes forever in either direction. So here you can see that we have two arcs. We know that this arc, the bigger arc, which is also a minor arc, is 80 degrees, and this one is 40 degrees. And based on these two numbers, we're actually able to figure out the measurement of this angle in the middle. They're vertical, so they're the same. And let's say we didn't know that they were 60, right? How could you think of a way or a method that you could use the numbers 80 and 40 to arrive at 60? Doesn't have to be complicated. Go ahead and take a couple seconds to think through that. Hopefully you noticed that the number 60 was directly in the middle of 40 and 80. If you notice that, perfect. So whenever your secant lines intersect inside of the circle, what we're going to do is we're going to take the average of it. So average means that you add different components up and you divide by the number. So in this case, we have two arcs. So we would be finding the sum of 80 and 40 and dividing by 2. And let's just make sure that works. So 80 plus 40 is going to give us 120, and 120 divided by 2 is 60, which is the exact number that we want. So as a general rule, whenever your secants are intersecting inside of the circle, in order to find the measurement of the angle, we find the sum of our two arcs and divide it by 2. If you look at this kind of looks like a plus sign, so that means that we're going to add our values. This formula is the same thing as this formula, except the work is done for you. Divide that by 2. This lands you with this formula. All right, so we looked at an example of intersecting secant lines inside of a circle. Let's see how things change when it's outside. We're trying to use the values of 160, the measurements of our two arcs, to get to 20. It's not as intuitive as what we did before, but it's a really similar process. Before, we found the sum of these two arcs to get our angle. Now, because this is smaller, instead of finding the sum, we're going to find the difference. So to use 160 to get to 20, we're going to do 100, and instead of plus, we're going to do minus 60, and we're going to divide that by 2, with the hopes that we'll get 20 degrees as the measurement of our angle. So 100 minus 60 is going to give us 40, and 40 divided by 2 is indeed 20 degrees. So again, when our lines are intersecting outside of the circle, the way that we would find the measurements is by finding the difference of our arcs and dividing by 2. And you can see that through this general rule. In this rule, we have two generic arc measurements. So we'll just say X and Y, we don't know what they are. And when we subtract them divided by 2, it gives us the measurement of our angles. This slide has all of the different formulas you would need to use. So I would pause this and take a picture of this. So when you're going through the examples, you know what formulas to continue to come back to. X represents the measurement of one of your arcs. Y represents the measurement of another arc. And N is the angle measurement, which we'll use going forward. All right, so now that we've learned the lesson, let's go ahead and do some examples. So when you're doing these examples, the main things you want to do are 1, you want to make sure that you label, and 2, you want to make sure you write whether the vertex is on the inside, outside, or on the circle. If you know these, you'll know which formula to use and how to apply it. So let's start with number 1. So number 1, I see that we have 2 arcs and an angle. For our arcs, we use x and y, so I'm going to label this x and y. I always put x with the bigger number because it helps in problems where we have to subtract. And our angle measurement, we don't know, so I'm just going to put the letter n. Now that we've labeled, the next thing is to look at the vertex. I notice that this vertex is outside of the circle, which means I'm going to use the formula that has to do with outside intersections, which is this one. So the formula is n equals x minus y divided by 2. And once we plug in our values, that should really help us get what we need. So n, we don't know what n is, so n is going to stay right here. We know x is 82, so this is 82 minus y is 26, and we divide by 2. So when we continue that on, 82 minus 26 is going to give us 56, and 56 divided by 2 is going to give us 28 degrees. So this 28 degrees represents that missing angle, and that would be our answer. Now let's move on to number 2. So number 2, we're going to approach this the same way we did number 1. The first step is to label your arcs and then our angle, and then figure out where our vertex is. So our first arc is on the outside right here. This is the bigger number. Our second arc is over here, our smaller arc. And then I'm going to change this to n. And the reason I change it to n is because in the formulas, n is always our angle. So now that we've done this, I see that your vertex, which is where the lines are meeting or intersecting, your vertex is inside, which means we're going to use the inside formula. Remember, this kind of looks like a plus sign, so that means we're going to use something that has a plus. So we're going to use n equals x plus y divided by 2, and we're going to plug in for what we have. We don't know n, so that's going to stay how it is. We know x is 120, we know y is 40, and we know we're going to divide it by 2. 120 plus 40 is going to give us 160, and 160 divided by 2, that's going to give us 80 degrees. And that's the measurement of this angle. And if you remember from last week, it's also the measurement of this angle. Let's say you wanted to challenge yourself, and not only did you need to know the measurement of these angles, you also had to know the measurement of this angle, which is its supplementary angle. These are supplementary because they both add up to 180 degrees because they're both on a straight line. So if you knew that this was 180 degrees, in order to figure out this angle, it would be the remainder of this. So it would be 180 minus 80, and this would be 100 degrees. So if this is 100, we know that this would also be 100 degrees. All right, on to number 3. So number 3, same process we did before. First step is to label. So the arc measurement that we have here is just x. We actually don't have a second arc. And that's not because anything's been done wrong, but this is because we actually learned this last week. These two chords meet on the circle, which means that this is an inscribed angle, which means this is half of this. If you don't believe that, this is on. So look for the formula for on, and you see that the measurement of this angle is this angle, or this arc, divided by 2. So this is our formula, x divided by 2. We don't know our angle, so it's going to be 52 divided by 2. And when you do that math, that's going to give you 26 degrees. And this would be your answer. So let's continue with what we've been doing before because it's been working. So the first step is we label. So we have our first arc, which is x. This time we're missing this arc, which means we're going to have to do something a little differently. I'm going to label this y, and we actually know our angle. We're going to label that n. So now that we've done that, we look at where our vertex is located, which is on the outside. And that means that we're going to use this formula. So we have n equals x minus y divided by 2. Now we have to plug in the correct pieces to the correct variables. So n, we actually know that n is 29. So 29 is going to go right here. X is 79. So this will be 79 minus, we don't know y. That's what we're going to solve for. So we need to solve for y, and there's a whole bunch of stuff attached to it, but it's okay. We can get rid of it. First thing we want to do is get rid of this pesky 2. And the way that we get rid of that is multiplying both sides by 2. When you do that, it crosses off this piece and that piece. And that's going to leave us with 29 times 2, which is 58. And that's equal to 79 minus y. Now we're still trying to solve for y. So let's get rid of 79. And the way that we do that is by subtracting from both sides, because this is positive and we want this to get down to 0. When we do that, we have negative 21 equals negative y. We want this to be positive. So we can negate this or divide by negative 1. And when you do that, I'm going to switch this around. That's going to give you a positive 21. So that negative just means that you're switching your sign. And this would be the measurement of this arc. On to our last problem. So same thing we were doing before, right? First step is to label. So I'm going to label this x and change this to y and label this with n. So we don't know our arc again. So this may look a little similar to what we did before. So because this vertex is located on the inside, we're going to use our inside formula. And using our inside formula, we'll see that we're going to have the measurement of our angle is equal to the sum of our arcs divided by 2. Remember, again, it looks kind of like a plus sign, so we use a plus sign. So our angle that we have is 60, that's n. So 60 equals our x, which is 55, plus we don't know what y is, and divide that by 2. With addition, it's a little less work, and you'll see why in a second. So we want to get rid of this 2, so we multiply both sides by 2 to cancel those out. And that's going to leave us with 120 equals 55 plus y. And then one more step. Last step is to get rid of this 55 by subtracting on both sides. And when you do that, you're going to get 65 is equal to y. And you could always switch this around if that bothers you and just say, it's an arrow, and just say y is equal to 65. So this would be 65 degrees. One last thing, because we want to make sure we actually know what we're doing. So if we know this is 60 degrees, we should also know that this is 60 degrees as well. And if we know this is 60, we can then figure out these two angles as well. So remember, these are supplementary, which means they add to give you 180. So to figure out this, it'd be 180 minus 60, which gives you 120 degrees. So that's 120, and so is that.